Hi, I'm Matt Desch, and I'm the CEO of the global satellite company called Iridium. I want to talk to you today about an important issue for the future of the near space shell that surrounds our planet. It concerns me as the CEO of a satellite company whose satellites circle the planet every day in that near space, and it concerns all of us in the space industry as it's a shared resource and in danger of being polluted. And there isn't currently an easier or straightforward way of cleaning it up. This seems to be the perfect topic for the Global Game Changers Summit participants, as the actions we take in the next 20 to 30 years could determine how safe the environment around our planet will be today and in the future, not just for the satellites and the important services that they provide humankind, but in a worst case scenario, whether it's even safe for humans to travel in and through near space as we endeavor someday to visit other planets and the stars. In the worst case scenario, we could in fact lock ourselves into our own proverbial house with no real way out. It's important to note what space brings to our lives each day. Navigation signals, communication, resource monitoring, asset tracking, banking services, weather forecasting, scientific research, and life saving services are just a few examples of what is enabled by space. In fact, the total global space economy, by some estimates, is nearing $500 billion this year. So, first, just a minute to say how my company is involved in this important issue. Iridium was the OG, as some of you might say, of the satellite companies operating in low Earth orbit. Now, by definition, low Earth orbit, or LEO as we say for short, is the part of space going from about 160 kilometers above us to about 2,000 kilometers. For those of you operating in miles, that's about 100 miles up to about 1,200 miles, which is a region still quite close to the Earth. For example, the International Space Station is only about 370 kilometers up. That's like the distance between London and Manchester, so it's still very close to the Earth. The Hubble Space Telescope, which is also quite valuable, is only a bit above that at 535 kilometers. Now, our satellites fly about twice as high as the International Space Station, up at 780 kilometers, but along with everything else in LEO, we go about 17,000 miles per hour, or that's 27,000 kilometers per hour if you think in those terms. Regardless, it's 4 times the speed of a bullet, going around the Earth every 100 minutes, each satellite circling the Earth about 14 times a day. Now, when our system was launched 26 years ago, it was the first commercial satellite system to be placed in low Earth orbit. Only US and Russian spy satellites flew in low Earth orbit before us. All other satellites before us were parked in an orbit very far above the Earth at the equator, 36,000 kilometers up in what is called a geo orbit. That's GEO for geosynchronous equatorial orbit, a little satellite, orbital 101 for you. Anyway, our vision was to create a service to connect people in remote places outside cell phone coverage, and over the years, we've become quite successful doing that. Cell phones only cover about 15% of the Earth's surface, so we cover the other 85%, or frankly, even the 15% when a natural disaster damages the cell phone towers. So if you want to call home from a ship on the oceans, or you're hiking in the mountains, or you're exploring the South Pole, or a natural disaster knocks out communication in your city, Iridium is the company that everyone depends on. Soon our technology will be embedded even into select Android smartphones, so you won't even need a satellite phone to help you in an emergency. So when we launched our first 66 satellites in the late 1990s, there were only 600 active satellites in space. Remember, the first satellite, called Sputnik, was only launched about 40 years before that, in 1957. We added, in only 1 year between 1997 and 98, 10% to the total number of active satellites. And everyone was quite freaked out for the first time about having so many satellites up in low Earth orbit. Now, as you can see, that situation has dramatically changed in recent years. The number has skyrocketed. More than 10 times the number of active satellites are in space today, and I'll talk about in a minute where that number is heading. By the way, most satellites are built to only last about 5 to 10 years in space. The longest ones, like ours, last about 20 years. Now, there's a couple ways that they can fail. The main ones are that they can run out of fuel used to keep their positioning in orbit, or their electronic or physical components die from just being bombarded year after year by solar radiation. Now, when our first system was first launched in 1997 and 1998, there were about 2,500 failed satellites or rocket stages still in orbit that had been launched and left in space from the previous 40 years. Those 2,500 dead objects, which we in the industry like to call rocks, were aimlessly traveling around the Earth at 27,000 kilometers per hour and slowly, very slowly, coming down towards Earth. Now, if you're a responsible satellite operator like Iridium, when your satellites get to their end of life in LEO, you command them to use up all their remaining fuel to lower their orbit, passivate their electronic components, and force them to catch or burn up in the upper atmosphere. At 1700 degrees Celsius, most satellites completely vaporize on reentry. We did that with our first generation system as we were completing our recent second generation replacement network, which we finished about 3 years ago. In fact, while the prevailing target is to remove satellites within 25 years of the end of their life, which, by the way, is way too long, we think it should be about 5 years or less, we were able to remove most of our satellites in only about 3 weeks from the end of each of their lives. Unfortunately, not everyone operates that way. Many satellites, particularly very small ones, are launched with no fuel or propulsion systems on board, or the ability to control themselves in orbit, or to deorbit themselves at the end of their life. Many satellites fail in space with no ability to command them to deorbit. Now, this can happen to even responsible operators, but with proper planning, everyone can greatly reduce the risk. When satellites fail, they stay in space a long time, which means they can't avoid other things in space. They are potential debris creators until their orbits naturally decay enough to burn up in the atmosphere. In fact, from our orbital altitude, gravity and atmospheric drag takes over 100 years to slowly decay a satellite enough to burn up. At the higher regions of low Earth orbit, it takes over 1,000 years to naturally decay. That's centuries of being in space, centuries of time for them to accidentally run into something else or something to run into them. Now, I joined Iridium 17 years ago in 2006. As I said, at that time, there were only about 2,500 things still in space. No one worried too much about that at the time because space, even just in low Earth orbit, is really, really large. I've tried to think of an analogy, but the volume of space around the planet, even only in that low Earth orbit up to about 2,000 kilometers, is really massive. Earth's surface is something like 510 billion square kilometers. So just if you even just simply multiply that by 2,000, and that's not exactly the formula, but it's over 1,000 trillion square kilometers. That's a quadrillion square kilometers. That's a lot of room. So no one was very worried 25 years ago about where things were going any more than you'd worry about sending a ship leaving Tokyo, Japan, randomly in one direction around the Earth and another one leaving from Perth, Australia in another direction, and worry that they might happen to run into each other somewhere out on the ocean. That is until 2007, when the Chinese first blew up one of their weather satellites with a missile and created thousands of new pieces of debris in space. The US blew up something in very low Earth orbit in 2008 just to demonstrate they had the technology. A little closer to my world, in February of 2009, a defunct Russian satellite collided with one of our satellites. And that was the first time in space that two things in almost 40 years had accidentally run into each other. That event was a watershed moment. Soon after that, the US government started providing satellite operators like us for the very first time with precise orbital information about all the objects they were tracking in space, so that we could start maneuvering our satellites around to avoid them. We actually move a satellite about once a week on the average to avoid some space junk that we're told one of our satellites might get close to in the coming days, something that we call a potential conjunction, which I can assure you we want to avoid. Today, thanks to these mishaps and some additional what I would call irresponsible anti-satellite tests by the Indians and Russians in 2019 and 21, there is now a lot of debris in space. Now, okay, the picture you see is typically what's shown. It's a bit over dramatized, making all the debris the size of a mountain so you can see it visually. But still, there's a lot. It's being tracked by the U.S. Space Force, who run a global network of sensors called the Space Surveillance Network, and they put the orbital information of each piece of tracked debris into a database called the Space Catalog that we can all access. Commercial and national operators, well, all of us except for the Russian and Chinese operators, the ones that all contribute information, and we share details about our satellites and our maneuvering plans to try to avoid any future crashes in space. Still, they're tracking over 27,000 pieces of space junk larger than a few centimeters in their database, and it's estimated there are well over 1 million pieces smaller than that. And even a small paint chip can puncture or damage a spacecraft if it hits it at 27,000 kilometers per hour. We've already had minor damage to our satellites in space from something very small hitting a solar array, for example. It doesn't happen often, but it does happen. As a result of all that, there's now a lot of concern about the mega satellite constellations currently being launched. SpaceX has launched over 4,000 Starlink satellites to date, and they plan to launch as many as 40,000 over time. Amazon plans to launch a similarly large constellation that they call Project Kuiper. And OneWeb, a European satellite operator, also has a very large constellation space up at the altitude where I told you that satellites take over 1,000 years to decay when they fail. There's another prospective operator called eSpace that raised some funding to try to launch over 100,000 satellites, and the numbers just keep growing in the race for space that's underway to bring all kinds of new services and capabilities to us on Earth. All of this activity, along with the debris already in space, is alarming nations and those of us who operate in low Earth orbit or want to. There's a lot of questions as to whether there's enough room for all of us in low Earth orbit and whether operators can keep up with all the potential conjunctions. I told you we're doing 50 maneuvers each year with our satellite. SpaceX's Starlink network is doing 50,000 collision avoidance maneuvers per year. Now, probably many of those are out of an abundance of caution, but the number is growing exponentially as they continue to grow their network. Perhaps you've heard of the Kessler syndrome, in which a NASA scientist named Donald Kessler postulated back in the late 1970s that if enough space debris occurred, given that it stays in space for hundreds or thousands of years, there would be a tipping point where the continued collision between the pieces would generate even more pieces, and the cascading effect would make the space around the Earth unusable for anyone, even too dangerous for anyone to fly up through LEO to get to deep space or beyond. You may have seen the movie Gravity with Sandra Bullock and George Clooney, where it was dramatized. Well, maybe a little over dramatized. And I don't want to underplay the problem, but we're nowhere near that point today. I think the problem with space debris, though, is at the point where climate change was 50 years ago. It's a warning to start doing something about it before it becomes the same problem we're starting to face with the climate today, where it might possibly be too late to reverse. Globally, among policymakers, space junk is appreciated as a concern, but unfortunately, there are no easy and quick answers, and commercial interests and investments continue to launch more satellites into space ahead of any regulations or limitations. Industry and national meetings have been organized to discuss the issue, but given the costs involved and lack of easy solutions, we're only in the early stages of solving it. And perhaps this is where some of you watching this session will get involved in either creating one of the technical solutions, solving the business case to make one of them work, or helping to create global policy agreements to keep the problem from becoming unmanageable in your lifetimes. Now, first of all, you may wonder if there is a technical solution. And there have been some interesting ones proposed, like a space tug that would go up and grapple onto the biggest pieces and pull them down into the Earth's atmosphere to burn up, or lasers shining up at debris to enhance drag and slow the debris down over time, thus reducing the time to decay and burn up. These are impractical so far because they're currently so expensive. At least a few $1 million just to remove even one object. So to completely solve the issue would take trillions of dollars, assuming they can even be made to work. Further, there's the inherent risk of these new space cleaners colliding themselves and creating just what they're trying to avoid, more debris. Companies have also emerged to improve the real-time databases we use to track debris using better and more ground radars. But it's not clear if they'll make enough revenue to do that to be successful. And even if they do, will the more precise orbital information make enough of a difference? On the policy front, the problems are recognized, but governments don't want to stymie growth of their space industries with excessive costs or penalties for bad behavior. And some of the largest spacefaring countries like China and Russia aren't even engaged with the global community on the issue. But there is some good news. Some of us commercial operators have gotten together and we've published best practices, which we're urging everyone to follow. And at least many of us in the US, Europe, Japan, and other like-minded countries are increasingly following that guidance, which is called Net Zero Space Initiative. Now, while there are no internationally implemented laws or regulations right now, all the largest space operators I'm aware of are no longer sending up satellites that can't be controlled and deorbited. At least any of them that operate above the altitude of the International Space Station, and all the mega constellations I'm aware of are planning for 5-year or shorter deorbits that we propose at the end of Satellites Live. Unfortunately, there's still a lot of satellites and rockets going into space there without an end-of-life disposal plan. Almost half of the satellite payload mass going to space today follows our satellites, but unfortunately half of it isn't, and 25% of the rocket body mass isn't either. Some satellites, despite good planning, fail unexpectedly before they can be safely oriented. And that's a problem, but one that we need to, that people can manage if they work and don't launch satellites with flaws in them. Now, no one is denying that space junk is a global issue to be solved, but we remain concerned that space, which once was agreed to by all to be a place of peace, is being planned for war. The US, Russian, and China have created killer satellites and other technologies to use in time of war that those of us in the industry believe are as unthinkable as using nuclear weapons here on Earth. We believe space should be off limits to the use of kinetic anti-satellite weapons of any kind, and all efforts should be spent on eliminating or at least stopping the further creation of any debris in space. Space is too important for all of us. For science, for navigation, for communication, or for future space travel, to be using it as a space of conflict. As you can see, the sustainability of the space around our planet is in a precarious and important state right now. And I've seen the problem be recognized and be taken seriously over the last 10 to 15 years, but it isn't solved yet. I hope many of you watching will join us in this exciting space industry and perhaps become part of the technical, industrial, policy game changers that are needed to make sure it doesn't become the problem that it could now. It would be unthinkable and is a perfect example of something called the tragedy of the commons. That's where everyone does their own thing to their own benefit, but ultimately we all lose. Space is a resource for all of us, and we all need to protect it. Thanks for listening. Take care.